Hey, what's up 3Ders? 3D Theory here. Today we're going to be talking about the large format 3D printer that Bambu Lab is about to release tomorrow on March 25th, 2025. It's called the H2D. Alright, let's break down this first teaser image from Bambu Lab. We're looking at the tool head with L extruder and right extruder or R extruder clearly labeled on it, which gives us a lot to work with for the upcoming H2D, set to release again tomorrow on March 25th. Here's my take on what this could mean. First off, the L and the R labels almost certainly point to a dual extruder system. This means that the H2D could have two independent extruders, left and right, built into a single tool head. Dual extruders are a big deal in 3D printing because they allow you to print with two different materials or colors simultaneously. Imagine printing a model with PLA for the main body and TPU for flexible joints, all in one go. Or you could use one extruder for PETG filament and the other for PLA supports, making post-processing a breeze. Bambu Lab has already multi-material capabilities with their automatic material system, AMS, on models like the X1 and P1 series. But a dual extruder toolhead could take this to the next level by eliminating the need to pause and swap filaments mid-print, making the process faster and more seamless. But let's dig deeper. What makes this dual extruder setup special? The design of the toolhead looks sleek and compact, which suggests Bambu Lab might have engineered a lightweight system to maintain high-speed printing without sacrificing precision. Bambu Lab is known for their Core XY kinematics, which allow for fast, accurate prints. And a dual extruder head that's optimized for speed could mean the H2D is targeting creators who need both versatility and performance. The compact design also hints at a potential improvement in thermal management. Dual extruders often struggle with heat creep or oozing when one nozzle is idle, but Bambu Lab might have cracked the code with advanced cooling or nozzle isolation tech. Let's also consider the H2D's potential target audience. The H2D name is still a bit of a mystery, but if we assume the H stands for something like hybrid or high performance, this dual extruder system could be part of a broader focus on advanced functionality. Maybe the H2D is a hybrid printer that combines FDM printing with another technology like resin or laser engraving, and the dual extruders are just one piece of the puzzle. Or it could be a high performance model aimed at prosumers who need a machine that can handle complex multi-material projects with ease. One more thought. What if the L and the R extruders are swappable or modular? Bambu Lab has a history of user-friendly designs, and a modular toolhead would let users customize their setup. For example, you could swap out one extruder for a high-temperature version to print materials like nylon or polycarbonate, while keeping the other for standard filaments like PLA. Or they might even offer specialized extruders for experimental materials like carbon fiber composites or metal-filled filaments, opening up new possibilities for advanced users. So to sum up, this teaser image of the toolhead with L extruder and R extruder strongly suggests the H2D will feature a dual extruder system likely optimized for multi-material printing, speed, and precision. It could also include advanced features like symmetrical printing models, modular extruders, or enhanced thermal management, all of which make the H2D a powerhouse for creators. Bambu Lab is clearly cooking up something exciting, and I can't wait to see how this fits into the bigger picture. This second teaser image from Bambu Lab is a stunning 3/4 view of the H2D's toolhead, and the caption, "The beauty of mechanics," really sets the tone. We're getting a closer look at the intricate internals of this toolhead, and there is a lot to unpack here. Let's explore what this could mean for the H2D and what Bambu Lab might be hinting at with this design. First, the transparent casing of the toolhead reveals a complex assembly of gears, motors, and filament pads, which screams precision engineering. This isn't just a toolhead, it's a masterpiece of mechanical design. The visible gears suggest a direct drive system, which is a big deal for 3D printing. Direct drive extruders place the motor right above the hot end, giving better control over filament extrusion compared to a Bowden setup. This means the H2D could excel at printing flexible filaments like TPU, or even tricky materials like PETG, with less stringing and better retraction. Bambu Lab already uses direct drive systems in their X1 and P1 series, but this toolhead looks even more refined. Maybe they've optimized the gear ratio for smoother, more reliable extrusion, or reduce the weight to maintain high-speed printing without losing accuracy. Speaking of speed, The compact and streamlined design of this tool head suggests it's built for Bambu Lab's signature Core XY kinematics, which allow for fast, precise movements. But what's really interesting is how lightweight it looks despite the dual extruder setup we saw in the first teaser. A lightweight tool head is crucial for maintaining high speeds without introducing vibrations or artifacts into your prints. Bambu Lab might have used advanced materials like carbon fiber or high-strength polymers for parts of the tool head to keep the weight down while ensuring durability. This could mean the H2D is aiming to set a new benchmark for print speed, potentially surpassing the already impressive speeds of the X1 Carbon, which can hit up to 500 millimeters per second with acceleration rates of 20,000 millimeters per second squared. Let's talk about those filament paths. There are two distinct tubes feeding into the tool head, which ties back to the L extruder and the R extruder labels from the first teaser. This confirms that the H2D is indeed a dual extruder printer, likely designed for multi-material or multicolor printing. But the way the filament paths are integrated looks incredibly clean and efficient. There is no clutter, which suggests Bambu Lab has put a lot of thought into reducing the risk of filament jams, a common issue with dual extruder systems. They might have implemented a new anti-clogging mechanism like a quick release filament path or even a sensor to detect jams and pause the print automatically. This would make the H2D super user-friendly, especially for creators who want to experiment with complex multi-material prints without the headache of constant maintenance. Another thing that stands out is the cooling system. While it's hard to see the exact details, the tool head's design hints at a robust cooling setup, possibly dual cooling fans or a more advanced airflow system. Dual extruder printers often struggle with cooling because one nozzle is idle while the other prints, leading to oozing or stringing. Bambu Lab might have developed a smart cooling solution like directional airflow that adjusts based on which extruder is active, or even a dual fan system with independent control for each nozzle. This would ensure clean, high-quality prints even when switching between materials mid-print, which is great for multi-material projects like functional prototypes or artistic models with multiple colors. The caption, "The beauty of mechanics," also makes me think about accessibility and maintenance. The transparent design isn't just for show, it could be a hint that H2D's toolhead is designed to be user serviceable. Maybe the casing is removable, allowing you to easily access the internal for cleaning, repairs, or upgrades. Bambu Lab has always prioritized user-friendly designs, and a toolhead that's easy to maintain would be a huge win for hobbyists and professionals alike. Imagine being able to swap out a worn gear or clean a filament path in minutes without needing a full teardown. That's the kind of thoughtful engineering Bambu Lab is known for. Let's also consider the bigger picture for the H2D. The focus on mechanics in this teaser suggests that Bambu Lab is doubling down on reliability and performance. The H2D might be positioned as a high-end model, possibly a successor 3D printing workhorse for prosumers or small businesses who need machines that can handle demanding projects without breaking a sweat. The dual extruder system, combined with this beautifully engineered toolhead, could mean the H2D is designed for advanced applications like printing functional parts with multiple materials, or even creating complex assemblies with dissolvable supports. One final speculation: what if the H2D isn't just a filament printer? The H in H2D could stand for hybrid, and this toolhead might be part of a multi-function system. Maybe Bambu Lab is experimenting with a hybrid printer that combines FDM printing with another technology like a laser engraver or a small CNC module, all integrated into one machine. The precision of this toolhead would be perfect for such a hybrid setup, allowing for seamless transitions between different functions. It's a long shot, but Bambu Lab loves to innovate, so I wouldn't rule it out. To wrap up, this three-quarter view of the toolhead reveals a lot about the H2D's potential. We're looking at a dual extruder, direct drive system with a focus on precision, speed, and reliability. The design suggests improvements in cooling, filament management, and user accessibility, all wrapped up in a lightweight, high-performance package. The H2D could be a dream machine for multi-material printing, with features that make it faster, cleaner, and easier to use than anything else on the market. Bambu Lab is clearly flexing their engineering chops with this one. This third teaser image from Bambu Lab is all about the motion system, with the caption, "The real servo motors," and an exploded view of a servo motor assembly. This gives us a big clue about how the H2D is going to move, and it's looking like Bambu Lab is taking things to a whole new level. Let's explore what this could mean for H2D and what kind of performance we might expect. First off, the use of the servo motors is a huge deal. Servo motors are a step up from the stepper motors commonly used in most 3D printers. While stepper motors are reliable and cost-effective, they operate in an open loop system, meaning they move a set of number of steps without feedback on their actual position. Servo motors, on the other hand, use a closed loop system with encoders to provide real-time feedback on their position, speed, and torque, and this makes them incredibly precise and responsive, which could mean the H2D is aiming for unparalleled accuracy in its movements. For 3D printing, this translates to smoother motion, fewer artifacts like ringing or ghosting on prints, and the ability to handle high-speed printing without losing precision. Bambu Lab already pushes the limits with their Core XY systems. Models like the X1 Carbon can hit speeds of 500 millimeters per second, with accelerations up to 20,000 millimeters per second squared. But servo motors could push the H2D even further, potentially reaching speeds of 600 millimeters per second or more while maintaining flawless print quality. Let's break down the components in this exploded view. We've got the motor housing, stator, rotor, bearings, and what looks like an encoder or sensor board on the far right. The presence of an encoder confirms that these are indeed closed-loop servo motors, which can self-correct if they detect any deviation in position. This is great for reliability. Imagine printing a complex model at high speed, and the printer automatically adjusts on the fly to ensure every layer is perfect. It could also reduce the need for manual tuning, like adjusting belt tension or calibrating acceleration settings, making the H2D more user-friendly for beginners while still offering pro-level performance for advanced users. The design of the servo motor looks robust and compact, which suggests Bambu Lab is focusing on durability and efficiency. Servo motors can generate more heat than stepper motors due to their higher performance, but the housing design here looks like it's optimized for dissipation, possibly with integrated cooling fans or a material choice like aluminum to keep temperatures in check. This would ensure the motors can run at peak performance for long print jobs without overheating, which is crucial for high-performance printers like the H2D. It also hints at a quieter operation. Servo motors, when properly tuned, can be much quieter than stepper motors, reducing the noise level compared to other high-speed printers. Imagine printing at blazing speeds without the usual buzzing noises that come from the printer. That'd be a dream for anyone with a printer in their home office. Another big implication of servo motors is their potential for advanced features, because servo motors offer precise control over torque and speed. The H2D could implement dynamic acceleration and deceleration profiles. This means the printer could slow down for intricate details and speed up for long, straight sections, all within the same print, optimizing both speed and quality. It could also enable better vibration compensation. Bambu Lab already uses input shaping in their current models to reduce vibrations, but servo motors could take this further, potentially eliminating artifacts entirely, even at extreme speeds. This would make the H2D a beast for printing highly detailed models like miniatures or engineering prototypes, where surface quality is critical. Let's also think about the real servo motors caption. What's Bambu Lab trying to emphasize here? The word real might be a subtle dig at other printers that claim to use servo-like features but still rely on stepper motors with basic feedback system. Bambu Lab could be signaling that the H2D is using true high-end servo motors, possibly with custom firmware to fully leverage their capabilities. This could give the H2D a competitive edge over the printers in its class, positioning it as a premium option for users who demand the best in speed, precision, and reliability. Finally, let's tie this back to the H2D's potential identity. The use of servo motors suggests that the H in H2D might stand for high performance or high precision. This printer could be aimed at prosumers or small businesses who need a machine who can handle demanding tasks like rapid prototyping, small batch production, or multi-material prints with absolute precision. Alternatively, if the H stands for hybrid, the servo motors could be part of a multi-function system, enabling precise movements for additional features like laser engraving or CNC milling alongside FDM printing. Bambu Lab loves to innovate, so a hybrid machine isn't out of the question. To sum up, This teaser image of the servo motors tells us that the H2D is going to be a high-performance beast with incredible precision and speed. The closed-loop servo system could enable smoother, quieter operation, dynamic acceleration, and advanced automation features, while pushing print speeds to new heights. This fourth teaser image from Bambu Lab is a real eye-catcher. The caption, "Industrial-grade accuracy, no longer a luxury," paired with an image of the head emitting a laser-like beam onto a checkered surface tells us that the H2D is packing some serious precision technology. Let's dive into what this could mean for the H2D and how it might change the game for 3D printing. First, let's talk about the laser-like beam coming from the toolhead. This strongly suggests that the H2D is equipped with a laser-based scanning or calibration system. The checkered surface below looks like a calibration grid, which is often used to map a printer's build plate for precise leveling. This could mean the H2D has an advanced auto bed leveling system that uses a laser to scan the build plate and create a detailed mesh of its surface. Most 3D printers use a physical probe, like a BL Touch sensor, to measure the bed's height at various points, but a laser system would be far more precise, potentially mapping the bed down to the micron level. This would ensure that the first layer of every print is absolutely perfect, even on a large build plate, reducing the risk of failed prints due to uneven leveling. For users printing large models or functional parts where precision is critical, this could be huge. But the laser might not just be for bed leveling. Let's think bigger. The caption, "Industrial grade accuracy," hints that the laser system could be part of a broader focus on precision across the entire printing process. One possibility is that the H2D uses the laser for real-time print monitoring. Imagine the laser scanning each layer as it's printed, checking for defects like warping, layer shifts, or under extrusion, and then adjusting the print parameters on the fly to correct them, possibly using AI. This kind of closed-loop feedback system would bring industrial-grade accuracy to the consumer-level printer, ensuring that every print comes out flawless, even at high speeds. Bambu Lab already has features like spaghetti detection in their current models, but a laser-based monitoring system would take print reliability to a whole new level. Another exciting possibility is that the laser is part of a 3D scanning system integrated into the toolhead. What if the H2D isn't just a printer but also a 3D scanner? The laser could be used to scan objects placed on the build plate, creating a digital 3D model that the printer can then replicate or modify. This would make the H2D a true all-in-one solution for creators. Scan an object, tweak the design and software, and print a perfect copy, all in one machine. The H in H2D might stand for hybrid, and this laser system could be the key, combining printing with scanning capabilities. For hobbyists, educators, or small businesses, this would be a dream feature, making it easier than ever to digitize and reproduce physical objects. Let's also consider the implications of industrial-grade accuracy, no longer a luxury. This suggests that the Bambu Lab is democratizing high-precision printing, bringing features typically found in expensive industrial machines to a more affordable price point. The laser system, combined with the servo motors we saw in the previous teaser, could enable tolerances as tight as ±0.01 millimeters, which is unheard of for most consumer 3D printers. This level of accuracy would make the H2D ideal for applications like engineering prototypes, medical models, or even jewelry design, where every micron counts. It could also tie into the dual-extruder system from the first teaser. Precise multi-material printing requires exact alignment between the two nozzles, and a laser-based calibration system could ensure that the left and right extruders are perfectly synchronized, even during complex prints. One more thought. What if the laser isn't just for scanning or calibration, but also for additional functionality? Bambu Lab has a history of innovation, and the H2D might include a laser engraving or cutting module alongside its FDM printing capabilities. The laser shown in the teaser could be powerful enough to engrave patterns onto printed parts, or even cut thin materials like acrylic or wood, adding a whole new dimension to what the H2D can do. This would make the H2D a true hybrid machine, capable of both additive and subtractive manufacturing, which would be a first for Bambu Lab and a huge selling point for creators who want a multifunctional tool. Finally, let's think about the user experience. The phrase, "no longer a luxury," implies that Bambu Lab is making this advanced technology accessible and easy to use. The laser system might be fully automated, requiring no user input. Just press a button and the H2D calibrates itself, scans the bed, and starts with printing industrial-grade precision. This would lower the barrier to entry for high-precision printing, making the H2D appealing to both beginners and professionals. It also aligns with Bambu Lab's reputation for user-friendly design. Think of how their current models handle auto bed leveling and filament swapping with the AMS. The H2D could take this automation even further, ensuring that anyone can achieve professional, quality results without a steep learning curve. To sum up, this teaser image of the tool head with a laser-like beam tells us that the H2D is going to deliver industrial-grade accuracy through an advanced laser-based system. This could mean super precise auto bed leveling, real-time print monitoring, integrated 3D scanning, or even laser engraving capabilities. Whatever it is, Bambu Lab is clearly aiming to make high-precision printing more accessible, potentially redefining what a consumer 3D printer can do. The H2D is shaping up to be a precision powerhouse, and I'm really excited to see how all these features come together. This fifth teaser image from Bambu Lab gives us a look at what seems to be a new and improved automatic material system, an AMS, for the H2D. With the intriguing caption, "Heating is not drying," we see filament spools inside a chamber with airflow lines indicating some kind of active system for managing the filament. This is a big clue about how the H2D will handle multi-material printing, so let's explore what this could mean and how it might elevate the printing experience. First, let's break down the caption. Heating is not drying. In 3D printing, filament drying is a critical step, especially for materials like nylon, PETG, or TPU, which are hygroscopic, meaning they absorb moisture from the air. Wet filament can cause issues like bubbling, poor layer adhesion, or stringing during printing. Many filament dryers on the market simply heat the filament to evaporate moisture, but this can sometimes degrade the material if not done carefully, especially for sensitive filaments. Bambu Lab's caption suggests that they've developed a smarter system that goes beyond just heating, likely an active drying solution that removes moisture without risking damage to the filament. The image shows a filament spool inside a chamber. The airflow line suggests that dry air is circulated around the spool, ensuring even drying without overheating the filaments. This would be a huge upgrade over traditional filament dryers, as it would preserve the filament's properties while ensuring it's perfectly dry for printing. For users working with advanced materials or in humid environments, this could be very useful, reducing print failures and improving overall quality. Let's tie this back to the H2D's dual-extruder system from the first teaser. The AMS is designed to manage multiple filament spools for multi-material or multicolor printing, and the H2D's dual extruders would need a reliable supply of dry filament to switch between materials seamlessly. If the AMS can actively dry filament during printing, it would eliminate the need to pre-dry spools in a separate device, streamlining the workflow. Imagine loading 4 different filament spools into the AMS, say PLA, TPU, PETG, and a dissolvable support material, and knowing that each one is being kept in perfect condition as you print. This would make multi-material printing on the H2D faster, easier, and more reliable, especially for complex projects that require frequent material swaps. Another possibility is that the AMS is designed to do more than just dry filament. It might also precondition the filament for optimal printing. The controlled heat and airflow could bring the filament to the ideal temperature and humidity level for the specific material, ensuring consistent extrusion and better layer adhesion. For example, some materials like nylon print better when they're slightly warm, as it improves flow through the nozzle. The AMS could heat the filament to just the right temperature without drying it too much, based on the material profile, which the H2D might automatically detect using RFID tags on the spools, a feature Bambu Lab already uses in their current AMS. This level of automation would make the H2D incredibly user-friendly, as it would handle all the filament prep for you, letting you focus on designing and printing. Let's also consider the broader implications for the H2D's target audience. The focus on proper filament management suggests that the H2D is designed for users who work with a wide range of materials, including advanced ones like carbon fiber-filled filaments, polycarbonate, or even metal-filled filaments, all of which are sensitive to moisture. This aligns with the industrial-grade accuracy theme from the previous teaser. The H2D might be aimed at prosumers, engineers, or small businesses who need a printer that can handle demanding applications without compromising on quality. A smart AMS with active drawing would ensure that every print, no matter the material, comes out perfect, making the H2D a versatile workhorse for professional grade projects. One more thought. What if the AMS is part of a larger ecosystem for the H2D? The heating is not drying system might be paired with other environmental controls like a heated build chamber to create the perfect printing conditions for advanced materials. A heated chamber is often necessary for materials like ABS or nylon to prevent warping, and the AMS can work in tandem with the chamber to maintain consistent temperature and humidity throughout the entire process. This would make the H2D a true all-in-one solution for high-performance printing, capable of tackling any material with ease. To sum up, this teaser image of the new AMS with the caption "Heating is not drying" tells us that the H2D will feature an advanced management system that actively dries and preconditions filament using a combination of heat and airflow. This could eliminate the need for separate filament dryers, improve print quality for moisture-sensitive materials, and streamline multi-material printing with a dual-extruder system. The AMS might also be more integrated, quieter, and smarter than the current version, making the H2D a dream machine for users who demand versatility and reliability. Bambu Lab is clearly thinking about the entire printing workflow with this printer. This sixth teaser image from Bambu Lab with the caption "Let there be light" and a toolhead emitting a bright blue light downward has sparked a lot of buzz in the community, and for good reason. Many people are suggesting that this blue light might not just be for illumination or sensing, but could actually be a laser for engraving or cutting. Let's explore the idea that the H2D might include a laser engraving module and what that could mean for this already impressive printer. Let's consider the blue light itself. The focused beam and the blue hue are consistent with a diode laser, which is commonly used in laser engraving and cutting systems. Diode lasers in the blue spectrum, typically around 450 nanometers, are popular for hobbyists and consumer-grade laser engravers because they offer a good balance of power and precision. And the caption "Let there be light" could be a playful way of hinting at the laser's ability to light up materials literally by engraving or cutting them with a concentrated beam. If the H2D's toolhead is indeed equipped with a laser module, this would make it a hybrid machine, combining FDM 3D printing with laser engraving capabilities, which would be a groundbreaking feature for Bambu Lab and a huge draw for creators. So what could a laser engraver on the H2D do? For one, it would allow users to engrave designs, patterns, or text onto a variety of materials like wood, acrylic, leather, or even the surface of 3D printed parts. Imagine printing a PLA model with the H2D's dual extruder system, then using the laser to etch a custom logo or intricate design onto the surface, like a QR code, all in one machine. This would be perfect for personalized gifts, custom signage, or adding professional-grade detailing to your prints without needing a separate laser engraver. The laser could also cut thin materials like 3mm plywood or acrylic, enabling users to create flat components that complement their 3D printed parts, such as enclosures, decorative panels, or even jewelry. Let's tie this back to the H2D's other feature. The servo motors from the third teaser would be a perfect match for a laser engraving system, as they provide the precise, smooth movements needed for detailed engraving work. Laser engraving requires exact control over the X and Y axis to trace intricate patterns, and the closed-loop servo system would ensure that the laser follows the design path with pinpoint accuracy, even at high speeds. This could make the H2D's laser module one of the most precise in its class, capable of engraving fine details that rival standalone laser engravers. The dual extruder toolhead from the first teaser also plays into this theory. The toolhead might be modular, allowing the laser module to be swapped in place of one of the extruders, or it could be a dedicated third tool that works alongside the left and right extruder. For example, the H2D could print a multi-material part using the dual extruders, then switch to the laser module to engrave a design on the finished print, all in a single workflow. This would streamline the creation process for complex projects like a 3D printed enclosure with an engraved label, or model with both printed and laser cut components. What about power and safety? A blue diode laser for engraving would likely be in the 5 watt to 10 watt range, which is typical for hobbyist laser engravers. This would be powerful enough to engrave materials like wood, acrylic, or some metals with the right settings, and possibly cut thin materials like 3mm plywood or 1mm acrylic. However, lasers can be dangerous if not handled properly. So Bambu Lab would likely include safety features, like its enclosed built chamber with a tinted window to block harmful laser light, or a safety interlock that disables the laser if the door is open. The H2D might also have a built-in air assist system common in laser engravers to blow away smoke and debris during engraving, ensuring clean cuts and reducing the risk of fire. The new AMS from the 5th teaser could also play a role by keeping filament dry and ready for printing, ensuring that the FDM side of the H2D works seamlessly alongside the laser engraving feature. Finally, let's consider the H2D's identity. If it does include a laser engraver, the H in H2D almost certainly stands for hybrid. This would position the H2D as a multifunctional machine aimed at creators who want to do more than just 3D printing. It would be perfect for makers, small businesses, or educators who need a single device that can handle both printing and engraving tasks, like creating custom prototypes, educational models, or small batch products with both printed and engraved elements. The industrial grade accuracy from the 4th teaser would ensure that both the printing and engraving are top-notch, while the servo motors and the advanced AMS would make the H2D a reliable all-in-one solution. To sum up, the community's theory that this blue light indicates a laser engraver makes a lot of sense. The H2D could feature a diode laser module for engraving and cutting integrated into its tool head alongside the dual-extruder. This would allow users to engrave designs onto prints or other materials, cut thin sheets, and combine 3D printing with laser engraving in a single workflow. With the precision of servo motors, the reliability of the new AMS, and Bambu Lab's focus on user-friendly design, the H2D could be a true hybrid machine, redefining what a 3D printer can do. The laser engraver feature would make the H2D a must-have for creators. And I'm even more excited to see it in action tomorrow when it releases.